Okay, so we were discussing exception handling. So just to recall that basically, exception is anything that takes you away from your normal execution path, right? A normal execution flow. Okay, so and of course exceptions should be handled, and how and when they are handled, of course, depends on the exception and the program. But what C++ provides, as we saw, through, so let me just go back to this thing. So yeah, so through this try, throw, and catch constructs, okay, C++ provides you a sort of a I would say a easy and a consistent mechanism for handling exceptions. Okay, so you can using try block, you can specify the portion of code which you want to monitor for exception. Okay, using the throw keyword, you can you can throw an exception, you can throw basically any object as an exception. We have discussed this, so long as that object has a destructor and a copy constructor. Okay, but it is advisable. So C++ also provides this class called the exception class. Actually, this should be exception, not exceptions. Okay, yeah, this is more like it. So C++ also provides this exception class, uh, which, along with how the exception handler are resolved, okay, allows you to actually create a hierarchy of exceptions like we discussed yesterday. Okay, but there is no hard and fast requirement. You can basically throw object of any class as exception. So basically this throw keyword allows you to sort of generate exceptions, if that is the term you want to use, wherein it basically creates an exception situation, and also creates optionally, so you can just create exception situation and no exception object. Okay, or you can also create an exception object, and then that exception object will be passed along with the exception. Okay, so this is one part. And then you have the catch keyword. Okay, so the catch keyword basically catches exception objects. Okay, basically, and then inside the catch keyword you can basically provide handler routine for that exception. So and you can have basically multiple catch keywords for every try block, and yeah, they are kind of scanned one by one in sequence. Okay, this is one thing. And basically, in the catch, in the catch handler, okay, you receive the exception object, okay, which was generated. Okay, and basically then you can use the information in that exception object to sort of handle, you can decide what to do with this exception. Okay, so like we discussed in this particular code, uh, you can either do something like you can just, for example, print it, or you can change some things. Okay, that is kind of, you can say, like you are handling the exception, so the exception is dealt with. Okay, so maybe if there's a divide by zero error, you may want to simply just add a very small number to the denominator. Okay, so that the divide by zero error doesn't come, or something like this. Okay, so if you have a square root of a negative number, okay, you can try to maybe generate a result which is of type complex rather than real. Okay, so this kind of things you can do to handle the exception. So this is one part of this, one part of one thing. But sometimes you cannot handle the exception. okay, right now. Okay, so what you do, you can just throw the exception again. Okay, so if you throw the exception again, basically, if this piece of code is being called by some other function where again, this is being this piece of code is being monitored. So the moment you throw the exception again, what happens is the subsequent execution just stops. Okay, so rest of the execution, at least for that part, will not happen. Okay, until and unless again that exception is caught by some other catch block. Okay. So here is a case where okay, so here is a case where oh sorry, yeah, okay, so here you can see a case where you have this particular yeah, so except line 1 and line 2, all other exceptions are thrown. Okay, but then this is inside this G function, which is also inside a try block here. Okay, so this is caught again by this particular exception. Okay, so that is possible. Okay, so that is why the exception mechanism is so useful and so yeah, compared to some other types of mechanisms that we have discussed already. Okay. Okay, so these things we have discussed. Yeah. 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 So this is what we were discussing basically, that yeah. Yeah, so when you when you do some sort of a throw expression, so what happens exactly? Okay, so expression is treated the same way as an argument to a function call. Okay, so now this is sort of getting into the details of how actually so if you say so let us again come back to this maybe particular, yeah, so this particular case. Okay, and now you see that this so here you are yeah, so here you are having this particular G function which is inside this try block. Okay, and inside the G function you are throwing this exception EX. Okay, so what is EX? EX is an expression actually, right? So instead of, so here we are just passing an object, but you could also put an expression here. Okay, so it could be like some operators which result in an object. Okay, now whatever this object is, the way this is passed into the catch block is basically just like a function call. Okay, so for example, in this case, you see the catch block is of a reference type. Okay, so a reference to this object will be passed here. Okay, whether that is a good idea or bad idea, you can understand. So obviously in this case, you can see that it's a bad idea because this EX object is created in a local stack. Okay, and sort of this this uh, um, yeah, okay, so but there is one thing here. Okay, let me go to that. Okay, so okay, I will come to this in a moment. Okay, what exactly happens? Okay, but as such, you can understand that a function argument or a call in a call or the operand of a return statement. Okay, so basically, if you pass by pointer, the pointer is passed. If you pass by reference, the reference is passed, and so on and so forth. Okay, now. Yeah, so okay, okay, uh, mm, okay. Yeah, so now you can, yeah, so the expression, you generate an object, exception object to throw. Okay, so basically, you generate the object something like this. Okay, or you can throw copies of an existing exception object. So you can create an exception object like this. Okay, and then you can throw a copy of this exception object. Okay, so now, yeah, so now the key thing here is that exception object is created on the free store. Okay, so actually here what happens is that this ex exception object, it seems like it is getting created on the stack. Okay, but when you use this throw ex, okay, actually a copy of this ex object is created in the free store and thrown. Okay, so this is the special treatment that this throw keyword gets. Okay, so hence, actually, even though this ex object is created on the stack here, actually what this catch receives is a copy of this ex object which is created in the free store. Clear. So actually that is why this is a good idea. So so I hope this mechanism is clear. Okay. Okay, so this is why it should be there. And once so then once it is handled, once the exception is handled, okay, the exception is also automatically destroyed. Okay, so you see, for example, this exception object is passed by reference here. Okay, so the exception object has been created in the free store, but once this exception is handled, after this, this exception object will be destroyed. Okay, so hence, if you remember, you can now understand why we need a destructor and a copy constructor for any class for which you sort of need to throw the exception. Okay, so copy constructor, because you have to copy this object. Okay, when you are throwing, so throw uses the copy constructor, and after the exception is handled, the exception object is destroyed by the catch block. Okay, for that reason, automatically it is destroyed automatically. Okay, so you don't have to call delete or anything.
Excuse me, sir.
Yes.
Sir, but copy construction is used when we want to call by value, but here we are calling by reference.
Yes, but in this particular case, it is not of, so that is what I'm saying. So this is a special thing. So when you do a throw, okay, so this is not a normal function call, right? So this is, you are throwing this exception. So what happens is that you create a copy of the object on the free store. And for creating this copy of the object on the free store, the copy constructor is used. And then that is passed by reference. Is this clear?
Yes, sir.
Okay, so the throw is creating the copy. Okay. Okay, so this is the thing now. Yeah. So yeah, so copy constructor and destructor should be supported. Okay. I think this part is clear. Yeah. And yeah, so yeah, so the type of the expression cannot be an incomplete type. Okay. So basically, you have to have a complete type. Complete type means basically if it is a class or a user defined type, then it has to be completely defined. It cannot be simply declared. Okay. Then you cannot create exception objects of that type. Okay, but you can create pointers to incomplete types as exceptions. Okay, so that is allowed. Okay, except void star. Okay, yeah, all versions of void star basically. Okay, so so suppose the exception class is not yet defined, you can still pass that exception to a a particular catch block. Okay, by using pointers. Okay, but yeah, so that is the thing. And in case of pointers, obviously, yeah, so it's a normal pointer arithmetic. So nothing happens there. Okay, nothing special happens there. So you have to basically create that object for which you are getting the pointer on the free store all by yourself. Okay, so you have to use the new keyword or something like that. Okay. Now, this is the other thing that sort of differentiates. So you see, there is two uses of this throw keyword. Okay, so in both these cases, you see you have a try block. Okay, so you have a try block here, and you have a try block here on the right, and you also so both of them are receiving, let's say, reference to a exception object EX. Okay. Now, in one case, you can pass on the reference. So that is called the rethrow on the right side. So what do? You simply say throw here. Okay. So what this does is it throws this particular exception object that you received as it is. Okay. So there is no copy, okay, made by this throw. Okay, and there is no destruction of the existing object. Okay, whereas if you say throw EX, in the end you will get the same thing, but this throw EX, as we mentioned earlier, this throw keyword is actually making a copy of this EX. So there is an original EX, but because you are doing this throw EX, it is actually making a copy of this EX object in the free store. Okay, and then the original EX object is destroyed. Clear? But if you simply throw, okay, without any argument, okay, so this method is called rethrow, which is obviously more efficient. Okay, so if you have no reason to create a new exception object and pass it, maybe because you have done some changes, or gathered some extra information, etc., then you may want to do this. But otherwise, what you do is you may want to throw multiple exceptions, etc. Many things can happen. Then you use this left mechanism, which is the throw again mechanism. Okay. Whereas if you just simply want to pass on the same exception, okay, then just rethrow it, okay, which will pass on the same exception to the the other try block, the which may be enclosing this particular code. Okay, is this clear? I hope this is clear. Okay, so now we have kind of come to the end of exception. So yeah, so what are the advantages of using an exception? So obviously, in the whole framework of object-oriented programming, so it is, for example, destructor savvy. So if you are if your programming practice is such that you are defining the destructors and everything properly for all the objects that you're doing, okay, then if you use the exception mechanism, then everything will be taken care of. So there are no loose ends sort of in a exception flow also. So there are no there are no memory leaks, there are no all the things that you can do in a destructor, like if you have open file handles, you can close them, all these things will still happen. Okay, it's unobtrusive. Okay, so you can see that it is implicit and automatic. So yeah, so basically your main code stays within the try block, and catch blocks are clearly separated from in the exception handling code. Okay. Yeah, so it is precise in the sense that, you know, you can use a particular exception object for your particular exception, and basically the type of that object encapsulates that particular exception situation. So whatever information you want to collect from that exception is part of that object. Okay, and then you can simply handle it using that using all the information that you have available in that exception object. Okay. Yeah, and basically for this you don't need to. So if you want to use exception class, then you need to include the exception header file. But otherwise, basically it's a language feature. It's not like it comes in a library or something. So it's a built-in language feature. So that is the other advantage. Okay. Yeah, so basically, see, this is the exception class. Okay, so broadly, it has this constructor. Okay, yeah, it has this copy constructor. It has the copy assignment operator. Sometimes you do the copy assignment. Okay, and it has this virtual destructor, which again, as you can understand, so because you can upcast on a hierarchy, so so this will result in calling of the correct destructor. Okay, and it also has a virtual what function. Okay, so what function basically returns a const char start, so it returns you some sort of an information. Okay, so if you want to just print the exception, okay, print information about the exception, you can use the what function. Okay, yeah, and you can re-implement it based on your type of exception. Okay, and here are some, this exception.h actually just defines all this. So invalid argument, this is one exception class. Okay, domain error, length error, out of range, etc. So you can just look at it. Again, related to typecasting, there are some built-in exception, like built-in as in it's defined in the standard library, C++ standard library, like bad type ID, bad cast, bad alloc, etc. Okay. Yeah, so you can just see a list of exceptions already defined. So in many cases, these kind of exceptions will serve your purpose. If they don't serve your purpose, you need something extra, you can also define your own exception class. You can also, inherit from one of these classes and define your own class, and things will just work properly. Okay. Okay, so yeah, so here is another list, a bigger list, I think. Yeah, I'll just leave you to look at it. Yeah. Okay, so this sort of ends our discussion on exceptions. So any questions or comments about exceptions? Okay, so in that case, we now go into our kind of semi-final topic, you can say, which is the function template. Okay, which is basically templates. Okay. So what are templates? As many of you know already, one of the things that C++ allows is what is called the generic programming. Okay, so what is generic programming? So basically one of the the core principles of this C++, and also you can say of object-oriented programming, is to have as much code reuse as possible. Okay, we know from we know that this is better in every way. So not only is the development effort reduced, that is just one part, but the more probably important thing is that your maintenance effort is also reduced. If you can reuse, if there is a certain functionality that you have already implemented in one part of the code, if you can reuse that instead of re-implementing, okay, that is going to automatically solve a lot of problems and a lot of bugs. Okay, so so with that, so what are templates? So templates are specifications of collections of functions or classes which are parameterized by types. Okay, so that is what is templates. Okay, so let us look at some example here. Okay, so suppose you consider the simple thing which is the max. Okay, so max is a function which takes two arguments as input. Okay, one is an so both are integers, let's say. Okay, and it returns the maximum of the two. Okay, now this could be for doubles, this could be for strings, this could be for complex numbers, and so on and so forth. Okay, and there could be so many things. In many of these cases, okay, the same algorithm works. Okay, so for example, probably in the first three cases here, which is int, double, and string, probably we don't know. Probably the same algorithm can work. Okay. For the complex, maybe a slight change in algorithm may be required. Maybe even for string, a slight change of algorithm may be required. Okay, but at least for int and double, exactly the same algorithm will work. Okay, okay. So how can we achieve this? Okay, so up till now, whatever we know, okay. Probably you will say, sir, best is to overload the max function, right? So you have this max function and you create many overloads of this max function. Okay, so in this particular case, the code has slightly changed because you have used strcmp, okay, instead of this comparison operator. But you could actually just define a class string, okay, and then you could define this greater than operator using strcmp, right? So actually this is just a matter of convenience that we are using strcmp here, but we can also use exactly the same code if we overload the operators correctly, and instead of cat star, maybe if we use the string class or something like that. Okay, okay, so yeah, so this is the case, and then so what is the problem with this, right? The problem is that there is re-implementation. Every time you do all these overloads, you have to actually specify the function body again. Okay, so here it does not look much because the function is small, but you can have very large functions, and in each of those cases you are basically doing a re-implementation. Okay, so how can you solve this problem of re-implementation? So again, a very dirty trick here is to use a macro, and actually many C programmers do this, and this is very bad because this is not safe, because you have already seen that if you have some sort of a side effect, like if you use max plus plus x and plus plus y, then one of the things gets incremented twice. So this is the thing where if we say something like I don't know, let me just say, yeah, so if you say max a plus plus and b plus plus, okay, and you are starting with a is equal to 3 and b is equal to 5, okay, so a becomes 4 at the end of it, but b becomes 7. Okay, so that is the problem. Okay, okay, so now, so then okay, yeah, so 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 what is a function template? Okay, so a function template describes, so again, so like you can think of it as you are now describing how different overloads can be built. Okay, so it is saying that a function template describes how a function should be built. Okay, so how does it do it? So it supplies the definition of the function using some arbitrary types, okay, as placeholders. So now instead of type, you also have variables. So you have type variables, you can say. Okay. So you can think of it as a parameterized definition. Okay, so the function definition, the function has some formal parameters, but the definition itself is parameterized by the type, the type parameters. Okay, so and we'll see how. Okay, um, can be considered as a set of overloaded function. Okay, is identified by the keyword template. Okay, let us come back to this. Okay, so we with an example. So this is easier to understand with an example. So this is an example. Okay, so this is how you define a template function. Okay, so you say template, and then within angle brackets, okay, so less than and greater than, okay, what you do is you provide the type. Okay, so you say class and then T. Okay, what this means is that T is actually the name of a type. Okay, and the next definition, the next function definition is actually parameterized by this type T. Okay, so this is what it is. Okay, so now you say T max, Tx, Ty, and then you put the code here. Okay, and now what you can do, you can simply call this max int AB. Okay, so AB are integers. Okay, does perfectly, so works perfectly. Okay, and again CD are kind of doubles. Okay, so you can call max double CD. Okay, and this will also produce the intended result. Okay, so this is the thing. Okay, now yeah, so the side effects problem is solved because each of these are proper functions. So their arguments are expressions which are properly evaluated, and it's not like the expressions are evaluated twice or anything. Yeah. So this A++ and B++ is actually supplied as it should be as an expression value. Okay. Yeah. Okay. Now. Okay. Now, what do we do about? So we have done it for um, for the double and the int, but there is a slight change in code for the char star. Okay. So what do you do? Okay. So what you can use is something called template specialization. Okay, so once you have declared a template function, something like this, okay, which we have already seen, okay, you can further specialize it. Okay, so how can you further specialize it? You can further specialize it. You say that template and you don't put anything inside. Okay, and then what you can do is you can say char star max within bracket char star, okay, and then char star x, char star y, and for this use this particular implementation. Okay, so you see, so this is the template implementation, and this is a specialized template implementation. Okay, so it has the same function name. Okay, now what it will do, so now if you call like this, okay, okay, it will so it will look at this char star here, and it will find that there is a specialized implementation of this char star. Okay, so it will take this specialized implementation over the generic implementation, which is already available here for any generic type T. Okay, so it will actually use this particular implementation. Okay. Yeah. So yeah. So you can see this that this is what is happening. Okay. Now one of the things is that the need to specify the type explicitly is sometimes bothersome. Okay, so you are specifying, when you are calling here, you are always specifying within angle bracket that type. Okay, now what can happen is that the C++, okay, can do an implicit instantiation by looking at the argument type. Okay, so what can happen? So let's say you have defined the same function template function here. Okay, now what you are doing, instead of calling max within, so a and b are both integers, so earlier you had to call max within angle brackets int and then a and b. What you can also do is you can simply call max of a and b. Okay, now in this template type, it knows that this is parameterized by this type t, but this type t has these arguments. Okay, so basically it can also decipher the type t by the type of the formal argument. Okay, so in this case both the arguments are of type t, and here we see that both the arguments are of type int. Okay, so it will instantiate an int version of this max call. Okay, and similarly here it will instantiate a double version of this max call. Okay. Okay, so this can also be done. So you can basically call max AB and max CD. Okay. Okay. So now this is the thing basically that we had this template function definition. Okay. Then we had this specialization where you have template char star max char star, and then so this has a sort of a redefinition of this function. Okay, and when you call this max AB and call max CD, so it basically binds to this max int and max double. Okay. But when you call it something like max S1 and S2, where S1 and S2 are character pointers, it binds to the specialization. Okay, so it will bind to this one. Okay, so even though you are not specifying char star within angle brackets here. Okay. Now, what happens is that suppose you so actually in this case there is a problem. Okay, so what is the problem? The problem is that suppose you have this template class which is taking sort of this type t as input and size. Okay, and it's trying to find a max from an array. So basically its input is this array of type t. Okay, and its output is an element of type t. So basically if you pass it an integer array, it will find the max of that and so on and so forth. Okay, but it has this size argument here. Okay, in this case you cannot do something like max of pval. Okay, the reason is that this size argument needs to be provided. Okay, so in this case this will lead to an error. Okay. Okay, so yeah, so basically the following kinds of conversions are allowed. So now obviously the question comes that how does this type matching happen? So if you do if you pass an expression, so you can pass an expression here as an argument. Okay, and it has to match to a particular type, and then the corresponding function will be called, and here basically three kinds of conversions are allowed. So so L value transformation, okay. Then qualification conversion, okay. Qualification is basically, you know, yeah, so const or something, okay. And conversion to a base class instantiation from a class template, okay. These are the only thing that are allowed. No other conversion. So for example, something like an implicit conversion, as you can understand, is not allowed. So if you pass an int argument, it will not be implicitly converted to double or something like that, okay. If this same template parameter found for more than one function argument, yeah, must be the same. So this is again, this is clear. So you cannot do something like, let's say, t of max of t of x and t of y, and then if you call max with one of them being integer and the other being double, that is not allowed. That is illegal. Okay. Okay, so so hope this is clear. Okay, if there are no more questions, okay. So now, okay. So now, so what can we do with this user-defined class? Okay, so we have this user-defined class complex. Okay. Now, what we have done, so we have this templated, implementation of max here. Okay. Okay. So what we do, we simply overload this operator greater than. Okay. So we do a normal overloading of the operator, and here we are saying that, if the norm is higher, then that particular complex number is greater. Okay. That is what we are saying here. Okay. Now, if we do this, it will simply work. So you can define complex number C1 and C2, and then you can simply call max of C1 and C2, and things will work exactly as though these C1 and C2 are some other type of objects. Okay, so so this is the thing. So you don't have to do any kind of redefinition here. Okay. Okay, now, yeah, so now we come to this other overload, which is that we want to overload max so that, it can find the max over an array, let's say. Okay, so then what do? We have this type t, but additionally, what we have here is this int size. Okay, so when you are calling here, so and then this function basically provides the computes the max for a templated type t, as you can see. So it takes an array of array t of size. Okay, and then it simply so it goes through. Yeah, so it loops through from I is equal to 0 to I less than size, and then it finds the max here. Okay. Now, at the time of calling, in this case, you have to call it the long way. Okay, so you have to call it like this. Okay, so you have to provide the type here. Okay, and you have to provide the size here. Okay, so notice that here the first one is a type argument. Okay, you are providing the type. Okay, but the second one is a value argument to the template. Okay, so basically what you can do, you can have one or more type arguments, and you can have one or more value arguments, which basically instantiate the templated function. Okay. Okay. So I hope this is clear. Huh? Okay. So now. Yeah. So again, another example. So this is just an example. So so we are creating a templated swap function. Okay. So it will swap basically any type t. Okay, and it is taking a reference to two reference to type t objects. Okay, And then the code is, you see, very, very similar to uh, the you know the swap the normal swap code, right? And so the reason this works is, so one of the thing that you should have is also the copy assignment operator for the templated type T. Okay, and then what you can see is that this works perfectly fine. Okay, so you can so anyway, integer works fine, so you see the swapped integers. Okay, but you can also create these string objects. Okay, and they also work fine. You can have this string objects, and the reason is that you are passing the original objects as references. Okay, so here when inside you create a new object, okay, using this. Okay, and then you use this copy assignment operator to keep copying things to the object. So first this one is copied to the new temp object, then other is copied to the one the object referred to by one, and then here. So everything works fine. Okay. Okay, now what happens is that because you are passing both uh, types and values as arguments, okay, so sometimes certain expressions can be confusing. Okay, so for example, look at this particular thing. Okay, so you are defining a function, a templated function f, okay, which has this type T. Okay, and then it is trying to define a pointer P of type T. Okay. Now consider this particular, so T colon name is the name of the type. Okay, but it could also be the so this could also be a value. So is it that you know T colon name? So these are the two confusions. Okay, so T colon name is a type and P is a pointer to that type. So that is one way to interpret this. Okay, the other way to interpret this is that T colon name is a value, and yeah, so it's a variable basically. Okay, and or the right way to think about it, it's an expression. Okay, and P is also an expression, and this is a multiplication operation. Okay, so how does the compiler um, um, so how can you sort of resolve this confusion? Okay, and the way to resolve this confusion is to explicitly use this type name keyword. Okay, so whenever you use this type name keyword, okay, in front of something like this, okay, the compiler knows. So actually in this one, the compiler thinks that this is a multiplication. Okay, but if you use this type name keyword, okay, it knows that this is actually a type. Okay, the first argument is a type, and hence this is actually a definition of a pointer of that particular type. Okay, so so basically yeah, so type name yeah, so you can see that here the keywords class and the keywords type name have almost the same meaning. So here also you see you are saying class T to denote to the compiler that T is actually the name of a type. Okay. But inside here you cannot obviously do that. So you because then it may be a nested class definition or something like that. So you use this type name keyword to say that this is actually a type. Okay. Okay. So I think with that, yeah, we have come to the end of this function templates. Okay, so any questions or comments about the function templates? There is a, I see that there is a, was there a comment? Okay. Yes, anybody, any comments, questions or comments? Okay. I don't know. I hope everything is clear. Okay, so okay, so we are actually almost out of time. Maybe I can just introduce. So there is the other thing about templates, which are the class templates. So up till now, what we have done is we have created templated functions. Okay, so just like we have created templated functions. Okay, we can also create templated types. Okay, so what are some of the examples of templated types that we can create, right? So so for example, one templated type that we can create is some sort of a data structure. Okay, so for example, a list, a queue. Okay, so we will see that as you use the STL, the standard template library of C++, you use many of this. So you use this vector, which is again a templated data structure. Okay, and so on and so forth. Okay. Okay. So here is an example of so here is an example that of a data structure like stack. Okay, and it is not a templated data structure. So you have one stack for character, and for every function is implemented using this character data as the type. So push takes a const char star ampersand item. Okay, uh, uh, top the top again returns a const char ampersand. Okay, and in this case it returns int. Okay, and it takes in int. Okay, okay, so this is how things are going. Okay. uh, Okay, so we can do pretty much the same thing as we did with. Is there a question? Hello.
Sir, the slides were not uploaded, like the exception slides, sir. So can you
Yes,
please
yes, yes.
upload
I
it,
will
sir?
upload it today itself. Yeah, yeah.
Thank you, sir.
Okay. Okay. So it's for template, it is the same idea. Okay. So you can basically say something like template class T. Okay. And then instead of defining a function, now here you are defining a class. Okay. And basically now this T becomes like the name of the type, and you can see that you can say T data 100, and then here you are for the push you are saying constant T ampersand item. Okay, and for the top you are taking constant T ampersand top. Okay, so you can do the same thing. Okay. Mm, yeah, so this creates a stack of type variable T. Okay, so you can create a stack. So by the way, how can you create the stack? So this is how you can create the stack. Okay, so stack of within bracket char will create the stack of type char. Okay, um, uh, and then you can do everything basically here. So this is, you are using a character stack for inverting a string. Okay. Um, okay. Yeah. Uh, so here, for example, so now you see, as you are defining this, so for example, you need to do here a copy, okay, of type T, okay. So you can only create this for that type T for which this copy assignment operator is defined, okay. So this copy assignment operator, so yeah, so the traits of type variable T include this copy assignment operator. So any type variable T for which you want to instantiate should have a copy assignment operator. So if it does not have a copy assignment operator, then this particular templated class cannot be used. Okay. 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 So yeah. So again, here we are using a stack of integers to do a postfix expression evaluation. I think you already know this. So yeah, so basically you have this postfix expressions, okay, and so there's an algorithm. I think most of you might know this already. That whenever you get two values, so the way you evaluate a postfix expression using a stack is that whenever you get two values, whenever you get values, you start pushing them in the stack, and whenever you get these operators, okay, you pull the last two values out of the stack, and then you evaluate it, and then you sort of push it back to the stack. Okay, so that is what is being done here. Okay. 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 Yeah, I think I will go into the details of. We are out of time, so we will spend some time on template class tomorrow, and then we will go into STL. So, any questions or comments?